Again, since these are general inferences based on scant archaeological and other evidences, I will just provide general frameworks of how things have changed in response to climate in terms of landscapes, of course environmental variables we talked about like rainfall, but how that converts into hydrological changes and fauna, and see at least get an idea of how they may have affected hominin behavior, populations, migrations, etc. as well. And we'll wander through different regions of the world as the information is made available in papers. So I'm taking this from a PNAS Proceedings of the National Academies of Sciences book on climate and humans. So it's looking at the US here, Wyoming region, looking at some evidence of hydrological changes, so location of Bighorn Basin and sites of paleo-hydrologic and paleo-temperature records. Again, just to add a little bit more detail, but to a more recent time. So we are always relying on this uniformitarian principle where we think processes that are happening now in terms of interactions between vegetation, climate, landscapes, fauna, also happened in the past. So any evidence we can get in the more recent times can be used for older times as well, except for the industrial era, post the Industrial Revolution, because this behavior is quite different than what happened in the past, right? So these are graphs of radiocarbon, paleohydrologic and paleotemperature records. Temperature changes are reconstructed from Yellowstone and Bighorn Mountain pollen cores. Moisture deficit changes reconstructed from Lake of the Woods paleographic record, and sees summed probability values, open and closed site curves, and averaged values in 50-year intervals. So it's an interesting plot because we start by looking at the normalized radiocarbon index, so going back to about this is like 15,000 or 14,000 years, so definitely after the glacial termination had started, and we had some hiccups in terms of the younger Dryas and so on. And so you can see closed and open and average values. I won't go into the details, but these are some of the probability values. And it's adding population estimates in terms of major periods of population increase as inferred from all available evidences. So you can see that generally there is a coincidence between warm periods and population increases, or maybe as we are coming out of the cold period, population increases even before the warming peaks, for example. Okay, so this is the precipitation and evapotranspiration, which is a good indicator of how precipitation changed and how vegetation and hence primary production resource availability may have changed. So that's effective moisture. Again, corresponds to wet periods in terms of population increases. You can see these here, local maxima. Drier periods are not showing this population increase. I have a strong wind again, so hopefully not affecting the recording. These are deviations of temperature from the baseline of 1895 to 1978 in degree centigrade. So we can see coming out we were warming with the hiccups, and the population increases correspond to some local maxima, but you have the Holocene optimum here where population had peaked. So there is again a population increase in these periods which correspond to various other combinations of things, but this is only for the this region, so we have to be careful on interpreting it. Moving the idea to looking at how refugia and other hydrologic changes and coastal habitats, etc., get formed. This is looking at a simplified model of springs associated with initial and final positions of the water table during glacial sea level fall. So when glaciers grow and sea level falls, what happens? Solid triangles are springs, spring oases here. Wavy lines are paleo sea levels shown here. So that's the sea level change. Solid line, land surface and sea floor. Broken line, groundwater table. Small arrows are main groundwater flow. Large arrows are groundwater flow to subaerial springs on emerged low sand shelf and to submarine reefs, knolls, mounds and pockmarks. Methane and water possible gas hydrates whose dissociation can favor vertical expulsions of gas and water. Springs formed on the shelf as sea level fell and continued functioning until the piezometric level dropped below the ground surface. Lots of details. Obviously, I won't go into those sorts of things, but you know that in the cold, deeper coastal sediments, methane can get locked up as clathrates or methane hydrates, which can get perturbed and release methane, which is a concern for global warming and maybe a player in the Paleocene-Eocene thermal maximum 55 million years ago. But in this context, it's just a indication of sea level change and potential exposure of the hydrates as well. So this is the low stand and the high stand of sea level change. There is the continental shelf, which typically is defined as depth of 200 meters, and you can see this is the land floor, sea floor, and these are the springs or oases. So you can see how groundwater table is being affected by the change in sea level, which basically means water availability and also vegetation change, hydrologic structure changes, lake levels and associated marine resource availability and so on and so forth. This is showing the topographically flat settings of lakes and rivers as landscape supporting environments suitable for hominins. This is from this paper here. See illustrate landscapes altered by small-scale tectonic activity. We already mentioned this a little bit. At a range of 10 to 25 kilometers, each landscape possesses different topographic features and associated capacities to support tree cover and plant and animal biodiversity. So we are being quite general in highlighting the processes of interaction between climate, environmental variables, geology, landscapes, refugia, and so on, and trying to put those in the context of archaeological evidences found about hominin dispersals and congregations and diversity and species successions and so on. So lake or pan landscapes, you can see how you can change or isolate water bodies and create a lake and have vegetation changes during wet and dry conditions. You can obviously seriously change the groundwater levels and hence the regions of water availability and vegetation. River landscapes also change during wet and dry conditions, showing where groundwater surfaces and where groundwater dips below the river level. So the river levels themselves change and vegetations change. Tectonically altered landscapes include uplifted dry flank, again groundwater levels showing wet and dry conditions. River gorges are formed, filled or emptied. Lakes can get formed by exposing water levels during wet periods. Rocky cliffs can get formed, creating different refugia and habitats, vegetation changes of course, swamplands which can offer different kind of resources, and river terraces as well. So kind of a broad idea of how landscapes, hydrology and vegetation and climate interacted and how humans may have been affected by these. So this shows the early human use of marine resources and pigments in South Africa during the Middle Pleistocene. Why am I showing it? Basically to say that all these climate changes are presumably a part of human evolution, behaviorally, anatomically, and in terms of expertise, maybe hidden talents, hidden expertise being exposed by climate perturbations. So the sophistication of the tools, similarity of tools between different regions and so on are obviously used, as we saw already, for inferring contacts between different groups that were not so proximal in location, and how they may have been forced to migrate or exchange expertise and cooperate to survive. Okay, so, and it shows how marine resources became used based on sea level changes and the kind of processes we are talking about here and here. Okay, so are they accidental discoveries or intentional explorations and so on, are obviously not easy to answer. So we'll come back and look at again little bit more details about various evidences and in fauna and landscapes and hominin habitat implications for the different regions during different MIS stages, and try to add this story. Obviously this entire chapter on human interactions with climate is about speculating using available evidences to make the links or connect the dots. Are there uncertainties in these? Of course there are, but we have to do the best we can anyways, and new evidences keep cropping up and modeling gets better in terms of reconstructing paleoclimate, paleovegetation and paleolandscapes. We'll look at reconstruction of land use during the Holocene, for example, in the next chapter, which shows us how we make advances on these in these fields. Okay.